Hello, everybody, and welcome to another wonderful day of chemistry. So today we're going to be wrapping up our conversation about reactivity and reactions by combining it with our previous discussion about solutions. So we want to try and figure out how I can predict things like theoretical yield of a reaction that involves, say, species in solution. And this is slightly problematic because most of the time what we're given is the volumes of each reactant that are being added into the system, along with the associated molarities. However, this isn't too bad when we remember that when we're dealing with reaction conversions, it should always be moles of reactant to moles of product or product to reactant. And because we're using these mole to mole conversions, as long as we have our molarity, we can convert any of our volumes into moles. And this again brings us to our old saying, when in doubt, mole it out. And because we have these molarities, in truth, dealing with reactants in solution can often be a lot easier than dealing with solid reactants because it's fairly easy to go from volume to moles using a molarity. And again, once we have the moles of reactant, we can then calculate the moles of product or any sort of other mole to mole conversion we might need to use. And this will essentially proceed as normal. However, one of the things you have to watch out for is that as we undergo chemical reactions and we mix together different solutions, our volume might change. And as the volume changes, well, this can have some unforeseen impacts on molarity as we're effectively diluting our solution. And this is a little bit kind of vague in concept. So let's go ahead and work in a quick example. So let's say I want to try and produce sodium chloride salt dissolved in water. And I'm going to do this by neutralizing some HCl with some sodium hydroxide. So acid plus base makes salt plus water. And so I'm going to do this by mixing 100 milliliters of 2 molar HCl with 150 milliliters of 1 molar sodium hydroxide. However, first thing we have to do, as always, is figure out who our limiting reagent is. So let's figure out how much sodium chloride can be produced from 100 milliliters of my acid. So in this case, we can go ahead and first convert milliliters of acid to liters of acid, and there to moles of acid, and then moles of salt produced. So again, using our molarity here and a 1-to-1 conversion. So it ends up turning out that the acid can produce about 0.2 moles of sodium chloride. We can repeat the same process with the sodium hydroxide. Note that we have a slightly higher initial volume, but a much lower initial molarity. Otherwise, conversion works pretty much the same, except for the sodium hydroxide will only produce about 0.15 moles of sodium chloride. So it turns out that sodium hydroxide is going to be my limiting reagent, and we can expect to produce about 0.15 moles of sodium chloride. Now we have to figure out what our volume is, because again, remember, I'm looking for the molarity of my product species. So if I add in 100 milliliters of acid with 200 milliliters of base, I should, in the end, have about 250 milliliters of total solution. Now, it is worth noting in practice, this volume might change a little bit due to the interaction of these two solutions, but it's pretty much about 250 milliliters. I can then use this to calculate my final molarity. Again, using the moles of salt produced divided by the total volume, I end up with a product of about 0.6 molar sodium chloride. And so again, in a lot of respects, doing stoichiometry with solution phase species can be easier than with solids, as you don't have to worry about those pesky molecular weights. However, whenever trying to calculate molarities, make sure you know you're very sure of exactly what the molarity refers to. In these initial cases, it refers to these solutions coming in. In this final case, it refers to that net product species. So as long as you mind your P's and Q's, you should be safe. So This brings us to the end of our chapter on reactivity. Next time, we're going to be talking a little bit more about atomic structure. Until then, take care.